This is a question from data structures. How many rotations are required during the construction of an avial tree if the following elements are to be added in the given sequence? That is 35, 50, 40, 25, 30, 60, 78, 20, 28. So first of all, what is an avial tree? Avial tree is a self-balancing binary search tree. So in avial tree, the height of two child subtrees of any node should differ by at most one. So balancing factor concept is there. Balancing factor. So height of two child subtree should differ by at most one. Should differ by at most one. And balancing factor is calculated as height of left subtree minus height of right subtree. And in avial tree, balancing factor at any node should be either -1, 0 or 1. And if any of this is violated, then appropriate rotations has to be performed. There are four types of rotation: RR rotation, LL rotation, LR rotation, and RL rotation. These are the different types of rotations that are to be performed. Now, based on this concept, let's try to solve it. Since the sequence is given, let's try to solve it. First, we will insert 35, then 50. So 35 is less than 50, so 50 comes here. Now the balancing factor is balanced because right now it is 0 minus 1. It will be -1 here and it will be 0 here. Now we are inserting 40. 40 is greater than 35 and less than 50. So 40 gets inserted here. Now the balancing factor gets changed. It will be 0 minus 2. So it will be -2 here. It will be 1 here. So the balancing factor got changed because of a insertion R and L. So we first perform a right rotation. That is, we rotate, we keep it at 35, then we rotate and put 40 here, then we put 50 here. So one right rotation has happened. A right rotate equal to 1 here. Now again the balancing factor is disturbed. It is -2, it is -1 and 0. Then we again perform one here also, right. Then we perform one left rotate. When we perform one left rotate, what happens is 40 gets to the top, 35 comes here, and 50 is here. Now the tree is balanced for the time being. So let's put a count here. One left rotate is also left rotate is equal to 1 here, and right rotate is also 1 here. Now we are inserting 25. When we insert 25, it is less than 40 and less than 35. So it is put here. Upon inserting 25, let's calculate the balancing level. Here it is 2 minus 1. It is 1 here. For this it is 1. For this it is 0, and for this also it is 0. Next we insert 30. Upon inserting 30, it is less than 40, less than 35, but greater than 25. So it becomes here. This causes a disturbance. So now what happens is, when calculating the balance factor, it becomes 1, 2, 3. 3 minus 1, it becomes 2. So this is imbalanced because of this rotation, that is L R. Now we are performing a rotation based on this. We perform one more left rotate. One more left rotate is performed, then it becomes like this: 40, 35, 30, 25, then it becomes 50. Now let's calculate the balance factor once again. Here the balance factor is 1, 2, 3. 3 minus 1, it becomes 2. Again this is unbalanced because of this. Now we perform one more. Here also it is unbalanced because of this. It will be 2 minus 0. So one more rotation we have to perform. That is, after performing this rotation, what happens is we have 40, one more left rotation, one more right rotation happens, 40, and 30 comes here, 35 comes here, 25 comes here, and 50 is placed here. So one more right rotation. So in total right now, 1, 2, 1, 2. For the time being, we are having 2 left and 2 right rotations, and currently this is the tree structure. Now let's try to insert the next values. We are now about to insert 60. So it will become 40, 30, 50, this will be 25, 35, then we are inserting 60. Once we insert 60, there is no issue. 1, here the balance factor is 2, the balance factor becomes 0. This is fine. Now we insert 78. Upon inserting 78, it becomes here. So let's try to calculate the balance factor of this root. It will be 2 minus 3. It will be minus 1. This is perfectly balanced. Now for this root, it will be 0 minus 1, 2. So it will become minus 2. Now because of a right rotation, this happens. So we perform one left rotate, left rotation. So as a result, what happens is the tree becomes 40, 30, 25, 35, then it becomes 60, it becomes 50 and 78. Now we'll try to check the balance factor of root. It is perfectly balanced. Here also it is perfectly balanced. Here also it is perfectly balanced. At all the places right now it is perfectly balanced. Now we'll insert 20. When 20 is inserted, it gets inserted here. Balancing factor becomes 3 here, 1, 2, 3 minus 2. It is perfectly balanced at root. Here it becomes 2 minus 1. It is also balanced. Here also it is balanced. Now after inserting 20, we have to insert 28. 28 gets inserted here. So here also it is perfectly balanced. So the tree is now perfectly balanced. So we count the total number of rotations. Previously we had performed 2 left and 2 right. Now we have again performed one more left rotation. So in total 3 left and 2 right rotations we have performed. Let's see from the options. We have three left rotations here and here, and 2 right rotations here. So based on the options, option C is the correct choice.